Hello, welcome to this webinar. As Chris says, I'm Adam Parks. I'm a modeler, hydrologist, and technical lead for Jacobs Digital Flood Products. So I've been in the industry for over 20 years, and the vast majority of that time has been spent hands-on developing models, hydrology, and analytics in support of flood risk management activities. So that's included flood risk mapping, so a lot of the flood maps you look at when you look at sort of go to the Environment Agency's website or other organisations' websites to see what's at flood risk, helping design flood alleviation schemes from very large tens of millions of pounds projects down to small local interventions, as well as more specialist things like reservoir safety, flood forecasting, urban flood risk, drainage management, and so on. I'm now responsible for many of our digital flood products, including Flood Modeler and Flood Platform, which are used in a lot of the projects we deliver, and also by our colleagues in other organisations. In this webinar, I'm going to look at specifically at flood risk management challenges for local authorities and other organisations. I'll be looking at some of the challenges you face, what responsibilities you have, as well as some of the technical improvement that have been made in recent years to make your lives easier, including some live demos at the end. So this slide moves forward. There we are. So first off, I'm going to have a look at who manages flood risk in the UK, who's responsible, who does what, and some of that explains some of the challenges around collaboration and coordination between different organisations. I'll then move on to some of the challenges specifically associated with those roles, focusing really on flood modelling, which is a particular challenge due to the size, complex nature of hydraulic modelling. So, who manages the water? As you're well aware, flood risk management is a devolved responsibility in the UK. So England, Scotland, Wales, Northern Ireland all have their own way of doing it. But even in England, which has the largest population and the most people at direct flood risk, there's a wide range of bodies involved in managing flood risk. So at the top of the tree, we have DEFRA, the government departments for environment, farming and rural affairs, who set the overall policy agenda. So they set the framework under which all the other bodies operate, as well as providing a good deal of funds required to manage flood risk. So directly funding the Environment Agency, partnership funding for flood alleviation schemes, and so on. The body everyone's familiar with is the Environment Agency at a national level. So the EA has a strategic overview role for all sorts of flood risk, as defined by the Flood and Water Management Act of 2010. But it's also directly responsible for managing flood risk activities on main rivers, so statutory main rivers and the coast. I'll come back to that in a second. It's also responsibility around managing reservoir safety for major reservoirs, and provides flood forecasting and flood warning services, again, for main rivers and coastal flooding. And that piece around main rivers is really important. So statutory main rivers account for less than 20% of the rivers in England. So there are many hundreds of thousands of kilometres of rivers in England alone, ranging from very small watercourses draining fields all the way up to the big rivers like the Thames, the Severn, and so on. But only a fraction of those are statutory main rivers under the direct responsibility of the Environment Agency. The remainder go down to other authorities. So zooming into a local level, we have lead local flood authorities. These are often councils or unitary authorities, so the top tier of local government, and they lead in the managing of flood risk. And that's from all sources. So again, so that's surface water, groundwater, non-main rivers, and so on. And a major role is coordinating between different risk management authorities. And there are many of them depending on where you are in the country and what the risk is. So if you're on the coast, you've got additional coastal risk. If you're in areas like the Fens, you've got a lot of artificial drainage and so on. District and borough councils, where they exist, are responsible for things like managing the flood risk for non-main rivers, as well as managing all of that surface water risk. Where we have the coast, we also have coastal protection authorities. These are local authorities adjacent to the coast who often combine with adjacent authorities to develop things like shoreline management plans, looking at how erosion and coastal change affect their areas and managing that. A major player in this are the privatised water utilities, so the likes of Thames Water, United Utilities, Northumbria. These manage the flood risk associated with their assets, and that's predominantly sewer systems, so making sure that the sewer networks run and that they don't cause flood risk. Many areas also have IDBs, internal drainage boards. These are bodies that exist where you've got artificial drainage. So lots of places like in the southwest of England, around Somerset, over in the Fens on the east, where you've got assets like artificial drains, pumps, sluice gates, and so on, features to manage flood risk and keep the land drained for originally agricultural purposes, but now more general flood risk management purposes as well. And finally, you have highway authorities, both at a national level, national highways level, and also all the way down to local authority. And like the water companies, they manage the flood risk associated with their assets with the roads and the drainage networks they have as well. And what you can see from this is that there's a large number of organizations involved in managing flood risk, and they need to collaborate with each other. There's nothing more frustrating than going on site during a flood and seeing, a load of people stood around a flood and trying to argue about whose water it was. Often the sources of flooding are complex and involve multiple bodies, and nothing is more frustrating to the public than people, not taking ownership of that flooding and trying to push the blame onto other people. Technically, that's often the case, but it is frustrating. What's evident is a large number of those organisations responsible for flood risk are local authorities through LLFAs, borough district councils, coastal protection authorities, highway authorities. There's a lot of responsibility placed on local authorities to manage flood risk, which is an increasingly complex and challenging area. So we've touched on some of the responsibilities of local authorities. The primary ones are managing flood risk from surface water, groundwater, water courses, and coordinating stakeholders. They also, at a local authority level, commission a lot of hydraulic modelling work and investigation. Hydraulic modelling is foundational to managing flood risk. Those models tell us where the risk is, how it's going to change with climate change in the future, how interventions like building a new housing estate or building a flood wall are going to change that flood risk. So they're really important to managing that risk. Another key area of responsibility is around land planning. So the planning authorities, again, local authorities, have responsibility to produce and review their local plans, taking account of flood risk, but also reviewing individual planning applications. The bigger, more complex ones are going to end up with the likes of the Environment Agency, where there's high susceptibility to flooding, or there's a significantly large development to alter local flood risk. But there'll still be thousands and thousands of flood risk assessments attached to planning applications, which will be the local planning authority's responsibility to review. And increasingly, they're using modelling data as part of those FRAs, and it lands on the local authority to be able to interpret that and do something with it. And with all public bodies, there's that need to be both transparent and accountable to the public. What decisions to be made, that scrutiny that's placed upon you. And that extends to data. So we've got freedom of information requests, FOIs. Models are a particular challenge in this regard because they are so large and complex. Models can now merrily run into terabytes in size for more complex schemes. So as I say, flood models are really important. So zooming in on that particular element, the models tell us where the flooding is and help us understand how to manage it. They help us plan how to manage it. But they are increasingly complex. Things have evolved. When I first started in the industry back in the early 2000s, we were using simple 1D only models, which could be in a few megabytes in size, perhaps a big one up to 100 megabytes, take a couple of hours to run maybe, and be fairly easy to ship around and share with people. Now we're running thousands of simulations. On the bigger projects, we're running hundreds of thousands of simulations in order to evaluate flood risk. Results are easily into gigabyte range for a single simulation and terabytes for entire projects. So things are getting far more complex. And we're also looking to collaborate more. We're looking to link up different sources of risk. We want to combine coastal risk with fluvial risk with urban risk, so those bodies can collaborate effectively. And collaboration is a real challenge. These models are really big and very complex, using specialist software to interrogate how do you collaborate between the different bodies I was looking at earlier in the presentation. Another issue is how do I manage that data? So we've got lots of data I want to visualize, I want to understand. How do I do that? How do I store that data in a sensible way so I can find it again? And how do I then share it with the community, with the public, to build their trust? And I'll look at that in a bit detail shortly. So very common challenges around model management are the data volume and complexity. I say how this has grown from megabyte range through the gigabytes, and now we're into terabytes of data. Certainly organizations like Jacobs have specialist management systems to manage modeling data specifically, but for local authorities, that's less likely to be the case. Have you got the capacity to manage that data, or does it often end up on hard drives? And can you find and access that data? The data is often fragmented across reports, emails, archives in different places. Can it be brought together? Version control is a real challenge. Not uncommon for, say, the Environment Agency to commission a model of an area, for a developer to pick that up as part of a flood risk assessment and make alterations to that, supply it to the local authority with an FRA. How does the local authority know that model's not dated by the Environment Agency, or how do those changes find their way back to the original model owner? Version control is a real challenge. Linked to that, you've got organizational constraints. These models are complex, require specialist knowledge to work with. So have you got the staff? Have you got the technical capability? Have you got the software in order to interact with it? And finally, cross-organizational barriers. If I'm working on a project, I'm say looking at a town or a city where I'm working on that modeling, how do I work with the local water utility companies, other government bodies, national bodies to understand that flood risk and ensure we come up with the right decisions? How do I share that data effectively? Just touching on visualization in particular, as I say, models require generally specialist software and expertise to interrogate. And as a result, we're often asked when we're producing modeling studies for, well, all clients actually, to produce lots of static images. Can you produce maps showing all the different flood outlines? Can you produce maps showing how the flooding expands over time? Can you produce all these different PDFs which help us understand the flood risk? Because most clients can't access the model data directly, and so they want all the static data. But they're often a compromise. You end up producing hundreds and hundreds of these maps, and it's not easy to then flick through those and find the ones you need or extract the data from it. So you often find people sort of measuring things off these static maps or trying to interpolate between different maps and so on. And that's not a really efficient way of working. And poor visualization hampers communication. It's great when you go to community engagement days for flood risk management schemes, and you can pop a model open up on a laptop, put up on a big screen, and you can talk people around what's going on. It really helps that engagement. I'll show you some of that in a minute. So that visualization is really important from a sort of transparency and community trust perspective, as well as ensuring you can do what you need to do as a local authority. Managing that data is a real challenge. A lot of data that can be distributed across multiple systems, and data loss is a real challenge. I can't count the number of times we've been provided with a model by a client, and that's at all levels, and asked to do some further work with it, and there's some key data missing. There may be a visualization file missing or a system file missing, and this is a real challenge to progressing that work, and it all ends up being inefficiency. It takes longer and longer to do things. Audit and review. Have you got the skills in-house to review the work done by your suppliers? If you've commissioned a model, how do you know that's been done appropriately and is working correctly? Equally, if you're receiving a model from a developer or by their consultant for a flood risk assessment, how do you check that model is appropriate, it's running correctly, the results are within expected parameters and so on? How can I do an audit of that without that specialist software or knowledge? So really what you need is somewhere managing that data in a structured way so you can apply efficiency and governance structures to it, and avoiding the cost of rework and abortive work. And just before we start to get into some live demonstrations of some of the tools we've got, we'll look at some data sharing. You are not going to be able to share models now via more traditional methods like email. Or even physical media transfer. They're just too big and slow, and it's unreliable, and it's hard to keep track of who's got what data and where it is. I say version control is a major issue. Have I got the most current version of this, what's changed as that data passes between organizations, because you may have a water company working on the model, the environment agency working on a model, a local authority, developers, consultants. How to track the versioning of that. And this all has an impact on collaboration and risk. Am I looking at the right data? Am I sharing the right data? Does everyone have access to the data they need to make the right decisions? And what does this all do? So this impacts on outcomes. So if you don't have the right data at the right time, and you slow down decision making. If you can't find that data point you need, it's going to slow down your decisions. And also that's going to reduce confidence in what you're doing. If you're not sure, if you don't think you've got the right model, you're less confident in the decisions you're making, and that increases the risk when we come to make the decisions and then defend and implement those decisions later on. And all this comes into rising cost and inefficiency. Obviously, all areas of government, particularly local government, have got cost constraints and pressures. The more efficiently we can deliver things, the better, because there's ever increasing pressures on cost. If we delay things, if we've got less confidence, we weaken our flood risk action. We're not necessarily making the right decisions, and we're not convincing the community we're making the right decisions. So being seen to do the right thing is as important as doing the right thing. You need that community reassurance. When it comes to quality and assurance, particularly around planning applications, it really has an impact. So are we approving the right things? We don't want to be approving planning, new developments which are unnecessary levels of flood risk or increasing flood risk elsewhere, because we're unable to assure the technical data that was coming across with them. So how do you address some of these challenges? So what do you need? You need a centralized data platform, so somewhere you can store your model data and access it across all your organization and share it with multiple organizations. You need to be able to visualize that data without specialist tools. You're not going to get the full suite of flood modeling data, flood modeler, HECRAS, InfoWorks, and so on a local laptop. It would cost a fortune. So how do you visualize that data effectively across different teams and different organizations? And finally, collaboration and governance. How do I collaborate with other flood risk management authorities, other organizations with a flood risk management role, water companies, IDBs, etc., and have governance in place to ensure that knowledge is retained, people are working effectively, and we've got that audit trail around what we're doing. So what I'm going to show you now is part of Flood Platform. This is a tool that Jacob's been using internally for about 15 years. It's now available externally, and what we use it for is model management. The thousands upon thousands of flood risk management studies we've undertaken over the years. This is where we manage our modeling data, where we can access it, we can share it across offices and teams, run simulations, also visualize that data. Let's pop open my browser. So Flood Platform is a browser-based tool. So this is just being opened in this case, Edge, I think. And it gives me access to model data across multiple organizations. These are the organizations I'm a member of down the left-hand side. Lots of testing organizations in here, because this is a large part of my role, is making sure our tools work as they should. And what I can do with these is I can access lots of model data that's been provided to us, and all of it has spatial data attached to it. Finding things is really important. So I just jump into another tab I've got open here. There's this little button at the top here which switches from a sort of a tile view to a map view, and this is an example. I can zoom out a bit because this is Australia, where Jacobs does a lot of work, and this is one of our clients, Melbourne Water, where they've got models covering the whole of Melbourne, and there are lots of complex models, and this helps you find them. So you can see visually where you've got models. You can click on those models, see their extent, and then jump into the you get key information about the models on the left hand side, and you can jump into the model data directly from these visualizations. And we're adding on to this to add 3D visualization and tracking as well. But there are multiple ways of finding your hydraulic models. If I jump into some UK examples, this is a team space consisting of multiple projects, and these are nice example models from around the UK. So you can see each model has got an area assigned to it. So this is Cleveland and Somerset. You can see where that is. An Edinburgh model, an Upper Mersey model in Manchester, an Upton upon Severn model down on the River Severn. And what I can do is I can upload models to this area, and we don't need a particular structure. This is the Clevedon models. This is a coastal model I'm having a look at, been uploaded. And if you've ever seen a two-flow model, they are not terribly user-friendly. So this is the contents of a two-flow model, and this is the command files associated with it. I mean, this means something to me, but I've been staring at these for decades, but they're not terribly user-friendly to non-modelers. What Flood Platform does is make this data usable to you. So when you upload a model, it's processed and it's broken down into simulations. This model's been run, I think 20 or 30 different times. And you can see the software's identified what the return period is for each of these and what the scenario is. So we've got 20-year undefended, 1,000-year defended, and so on. And you can also see of the simulations that have been provided, which ones have been run. So not all of these have been run, but the ones in green, which can be complete, have been run, and we've got model data we can access. And I'll just jump to the 5-year undefended. And this is where it's presenting some of that complex model data in a more understandable way. I can start to see all the parameters set up. I can also see some of these key diagnostics around control numbers, time steps, and so on, and check the model's performing correctly, as well as access the logs. But most importantly, I can access the results in a browser. So this is this is Clevedon down in Somerset. Zoom in again. And you can see this is a coastal model. So we've got coastal flood risk here, and the water's inundating into the town. What I've done is I've just switched on the depth results from this 2D model. And if I want to, I can see the maximum. So click a little button. I can see the maximum flood depth in Clevedon, or I can time step animate through it. So I can use this toggle bar to animate through the results and see the expanding flood wave. Let's just chuck the arrows on there as well. So you can see where that flooding goes. And as I zoom in on this, the resolution jumps up. So you can see down to individual house levels, what's going on, where the water's flowing down here into the Blind Joe River here. And I can click anywhere I like, and I can get results out of this. So I'll just switch those arrows off and click on the inspector tool. Whenever I click, it tells me what the results are. So I can look at a particular house, and I can click, and I can see what the estimated, the modeled flood depth is at that location, or the velocity or water level, time of whatever output the model's giving me. I can also access 1D results. In this case, this model's got some drains over here. So if I just go forward a bit, you can see the water discharges to the coast via this flat outfall. So if I click on that, I can see what that looks like. It's a 5-meter pipe. I can see the flow and water levels in that, so I can understand what's going on. And I've also got tools in here to measure off. So I've got some measuring tools in here. I can measure off areas at flood risk. So maybe you want to see what this area here, this dry island looks like. So I can measure that off and export that. I can measure areas of floodplain loss and so on. Just click that off. I've got tools to let me create screen grabs of this. So if I want to share this with people, I can just easily do that as a PNG, click download, and a little file is created for me, letting me see that flood risk and share it with other people. And a really nice tool also is I can comment on it. So if I've got this model in here, I can put comments in. So it may be comments perhaps to your supplier, comments to colleagues in different departments or organizations. Anyone can access these comments and they can reply to them. So it may be and all this keeps a provenance chain, and these can be shared really easily. So if I go back to my my model, I can see who can access this model. At the moment, it's just me and my organization, but I could add external users to this as well. So I may want to share that with someone external. So if there's someone who's not currently a member, I can add them to the invitee list, and they'll be added as a visiting member. And they'll be able to jump in and do the same things I've just done. They'll be able to see those results. They'll be able to interact with those results and add comments as well, but you can limit what they can do. You can stop them from deleting data, adding new data, or initiating simulations. And it is worth mentioning, go back to that model. You can also run simulations in here. So all those simulations I saw, the ones that hadn't been run, I can choose any of those I want. And if I want to run them in Flood Platform, I can. You don't need to get new an external supplier to go and rerun that. You can simply click add to queue, and you can rerun that model directly within Flood Platform. Just really quickly, I'll show you a different model type. So I'll jump into a linked flood modeler 2-flow model. So this is the River Severn at Upton. Just going to quickly switch off those velocity arrows. And so what this is showing you is a model that comprises a 1D model in the channel and then a 2D model in the floodplain. And again, you can access these results really easily. So you've got all these cross sections. So rather than needing flood model on your desktop, you can simply click on a cross section. You can see the water levels in here, and the time, stage, flow data as well can be readily accessed.